In this video, we're going to talk about suggested homework problems from 2.3. There's a lot of problems for this section, so I'm actually going to split it into two videos for you. So this first video, we're going to cover just the product and quotient rule problems. We'll come back in another video and talk about the tangent line problems and the um, uh, higher order derivative problems and some application problems and things like that. So some of those problems in the next video will require the use of the product and quotient rules that we're going to talk about this time. So let's talk about what is the product and quotient rule. I'm probably going to use a little different notation than you saw in your book. So let U and V be functions of X here. And then if Y is equal to the product of U and V, that I'll notate with a multiplication dot. To be explicit, I could just call it UV. Then the derivative of Y is going to be, and I'll write that as U prime V plus V prime U. Your book may write that a little differently because it may differentiate second or write these terms in a different order or something like that. It won't matter because of the commutative property of multiplication and addition. This is just how I learned it, to always differentiate the first one first and then differentiate the second one second. It's easy for me to remember that. So that's how I always write it out. And the quotient, so this is the product rule because it's a product of two functions. And then the quotient rule, if Y is equal to the quotient of U and V, then Y prime is going to be, and you have to differentiate the numerator first here. So this is really the reason why I learned the product rule the way that I did, because the numerator of this quotient rule is almost identical, except for it's a minus sign instead of a plus sign. Don't forget there's a V squared in the denominator, so it's U prime V minus V prime U all over V squared. This is the quotient rule. Now, I don't think that you'll have a problem remembering which one is plus and which one is minus. But just to give a little bit of foreshadowing here, that the reason this has addition has something to do with the fact of log of multiplication on the inside turns into addition of logs like that when we expand logs, and that if I have a quotient on the inside of a log like this, that turns into subtraction of logs. And this doesn't look like it has anything to do with logs right now, but I promise you that when we get later on in calculus, you'll actually prove these two rules with some differentiation techniques that involve logs, and you'll see how this one with the product is related to this multiplication rule, and this one with division is related to the subtraction rule, and that's why this one has a plus sign and this one has a minus sign. All right, that's enough of supplemental notes for you. Let's jump into the problems, and you'll see that I'm going to write the rule down every single time, even though I've been doing this for many, many years and tutor this on a daily basis. I do not do these problems without making my substitutions. So I make a little chart off to the side that my first function is 2x minus 3, and my second function is 1 minus 5x, and the derivative of my first function is 2. The derivative of my second function is negative 5, And so I'm going to write g of x as my first function times my second function. And then I'm going to write my product rule that the derivative of g is the derivative of my first function times my second function plus the derivative of my second function times my first function. And then I'll go ahead and make these substitutions for my chart. U prime is 2, v is 1 minus 5x. That makes this part of the multiplication here, plus v prime is -5, and u is 2x minus 3, and that makes this part here, and it makes a nice x. Don't tell your teacher that you're cross multiplying. You're not. It's only in proportions that we cross multiply. I just want you to see that it makes an x, that you're supposed to multiply opposite corners like that in your chart. So that's the usefulness of this chart, is that in the product rule, it doesn't matter which way you multiply first, as long as you multiply top left corner times bottom right corner and add it to bottom left corner times top right corner in some way, you're going to get the right answer. Just don't multiply up and down or left and right. As long as you have your chart set up with u and then u prime below it and v prime below it, and multiply diagonally and add those products together, you're going to get the right answer. So 2 times 1 is 2. 2 times -5x is -10x. -5 times 2x is -10x. -5 times -3 is +15. So g prime is 15 plus 2 is 17 minus 20x. So that was all number 5. We'll be able to go a little faster with the next problem because I won't have to do as much explanation of the product rule next time. All right, let's look at number 9. If f of x is equal to x cubed cosine of x, I have u is equal to x cubed and v is equal to cosine of x, which makes u prime equal to 3x squared and v prime equal to a negative sine x. So f of x is equal to u times v. F prime of x is equal to u prime v plus v prime u. F prime of x is equal to 3x squared cosine of x minus sine x times x cubed. And I just don't like that order for that second one. So I want my x's to go before my trig functions so that it's clear what's inside of my trig function. All right, now let's look at number 11, which is going to be the quotient rule. So number 11 says f of x is equal to x divided by x minus 5. So my u is x and my v is x minus 5. U prime is 1 and v prime is also 1. F is u divided by v, and f prime will be u prime v minus v prime u all over v squared. F prime is 1 times x minus 5 minus 1 times x over x minus 5 quantity squared. I told you last time with the product rule that it didn't matter what order you multiplied and then added in. Order matters this time because of subtraction, because a minus d and b minus a don't give you the same answer. They give you opposite answers. So you must multiply u prime times v first, and then subtract v prime times u second. Order matters this time. So bottom left to top right first, minus bottom right to top left. So x minus x will zero out and give me a -5 for my numerator, and x minus 5 quantity squared for my denominator. If there's no common denominator in the numerator, or if there's no common factor in the numerator or denominator, it's fine to just leave the denominator squared like that. There's no reason to multiply it out unless the problem or the teacher tells you that you need to. But our goal is to try and cancel out common factors if we can when we simplify here. And if we know we can't do that, then we can just leave the numerator simplified and the denominator simplified. Let's look at number 15 now. G of x is going to be sine of x divided by x squared. So my u will be sine of x, and my v will be x squared, and my u prime is going to be cosine of x, and my v prime is going to be 2x. So g of x is u divided by v, and that makes g prime equal to u prime v minus v prime u all over v squared. So my g prime is going to be cosine of x times x squared minus 2x times sine of x over x squared quantity squared. So g prime of x is x squared cosine of x minus 2x sine of x over x to the fourth. Now I see that there's x's in everything, so I am going to factor a common factor of x out. This will cancel here, and that will leave me with the final answer for g prime of x cosine of x minus 2 sine of x divided by x to the third. All right. Let's look now at number 19. And we're told to evaluate the derivative at the specific value of c. So f of x is equal to x squared minus 4 over x minus 3. There's no common factors to simplify first, given c is equal to 1. So f, let's identify u and v, x squared minus 4 and x minus 3, and u prime is 2x and v prime is 1. F of x is u divided by v. F prime of x is u prime v minus v prime u all over v squared. F prime of x is 2x times x minus 3 minus 1 times x squared minus 4 over x minus 3 quantity squared. That's something that's different this time because I'm evaluating at a specific x value. I can go ahead and I can plug in x here without simplifying my numerator and denominator if that would be helpful. So let me go ahead and show that to you. If I stick 1 in here, this is 2 times 1 times 1 minus 3 minus 1 times 1 squared minus 4 over 1 minus 3 quantity squared, and that's not going to change my final answer. So 2 times negative 2 minus, that 1's not going to change anything, 1 minus 4 is a negative 3 over negative 2 squared. So this is f prime of 1 is a negative 4 plus 3 over 4. That's a negative 1/4 for my slope there. All right, let's look at 21. If f of x is equal to x cosine of x, and c is given to me as pi over 4, my u is equal to x, and my v is equal to cosine of x, and u prime is 1, and v prime is a negative sine x. My f of x is equal to u times v, and my f prime of x is equal to u prime v plus v prime u. So f prime of x is equal to 1 times cosine of x plus a negative sine x times x. F prime of pi over 4 is cosine of pi over 4 minus pi over 4 times sine of pi over 4. This is square root of 2 over 2 minus pi over 4 times square root of 2 over 2. And you can approximate that with your calculator if you would like to do so. I'm just going to probably make a common denominator here and multiply by 4 over 4 here and make this 4 root 2 minus pi root 2 over 8 as my simplified answer. If you want to take the square root of 2 out of that, I think that would also be okay. Let's look now at number 31. And we're just told to find the derivative. We're not told what rule to use. Some of these will require product or quotient rules, others will not. So I see it written as a product, so let's go ahead and define it that way. You may already notice that I'm going to have a quotient inside, so I'll deal with that when I get there. So u prime is 1, v prime is going to be 0 minus, and then the derivative of 4 over x plus 3. So I'll just write that for right now. and deal with that when I get there. Let's just keep that negative on the inside. The derivative with respect to x of a -4 over x plus 3. All right, so f prime of x is 1 times 1 minus 4 over x plus 3 plus the derivative with respect to x of -4 over x plus 3 times x, and so we have I'll open a set of parentheses here, and now I have a new portion here that is a quotient. U is -4 and v is x plus 3 and u prime is 0, v prime is 1. So I'm going to call this now a new u over v substitution. And so f prime of x is 1 minus 4 over x plus 3 plus x times, and then this is going to be u prime v minus v prime u all over v squared here. F prime of x is 1 minus 4 over x plus 3 plus x times, and then this is 0 minus 1 times -4 over x plus 3 quantity squared. So f prime of x is 1 minus 4 over x plus 3 plus x times 4 over x plus 3 quantity squared. Simplify that one more step here. F prime of x is 1 minus 4 over x plus 3 plus 4x over x plus 3 quantity squared. Was that the only way to do that problem? No. You could have tried to remove the parentheses first with multiplication. But that is what I see as the best option for explaining this first with product and quotient rule, since it involved both a product and a quotient. So it also had a sum difference rule in there, so it was kind of interesting. Now number 33, I'm not going to have to use the quotient rule. I can use the quotient rule if I want to, but there's nothing making me use the quotient rule, so I won't use it. So 33 is f of x is 3x minus 1 over the square root of x. Notice that it's a monomial in the denominator. So this is 3x over x to the 1/2 minus 1 over x to the 1/2. So f of x is equal to 3x to the 1/2 power minus x to the -1/2 power, and I'm back to the product rule now, or power rule. So 3 times 1/2 is 3/2. Drop the exponent by 1. -1/2 times -1 is +1/2. Drop the exponent by 1. And then we're going to write this with a common denominator here in a second, but let me bring my negative exponents down for you. So I would like to multiply by x over x here so that I can get 2x to the 3/2 in the denominator in both fractions. That will be 3x plus 1 over 2x to the 3/2, and that looks pretty close to what I started off with. I'll leave it like that, even though this is fractional and this is a root. Typically, when we end up with improper rational exponents like this, we like to leave them like that instead of writing it back as a root. So if you would like to rationalize the denominator and multiply everything by x to the 1/2, top and bottom, you can do that. I kind of advise against that because you could be looking like you're adding an additional 0 into the numerator when you try to find zeros of this later. So be careful about doing that. That was number 33. Let's look at number 39. So f of x is equal to 2x to the 3rd plus 5x times x minus 3 times x plus 2. And you may say, wait a second, I thought my product rule only had u and v. How am I going to multiply 3 terms? You are correct that you only have a product rule that multiplies u and v. So you need to take 2 of these factors and multiply them together. Let's take the 2 small ones and multiply them together because that's easier. So 2 smaller degree and smaller, they're all the same number of terms. So let's take x minus 3 times x plus 2 to get x squared minus x minus 6. And now I have a nice u and v. F of x equals u times v, with u equal to 2x cubed plus 5x and v equal to x squared minus x minus 6. U prime will be 6x squared plus 5. V prime is 2x minus 1. F prime of x is u prime v plus v prime u. F prime is 6x squared plus 5 times x squared minus x minus 6 plus 2x minus 1 times 2x cubed plus 5x. So f prime of x is 6x to the 4th minus 6x to the 3rd minus 36x squared plus 5x squared minus 5x minus 30, and then plus 2 times 2 is 4x to the 4th. 2 times 5 is 10. X times x is x squared minus 2x to the 3rd minus 5x. So f prime of x is going to be 6x to the 4th plus 4x to the 4th is 10x to the 4th. Now I'm going to look at my x cubed terms. Negative 6 and negative 2 is negative 8x cubed. Now I'm going to look at my x squared terms, and there's a few of them. So negative 26 plus 5 is negative 21. X squared. And there's a couple x terms, so negative 5 and negative 5 is negative 10. And then this constant of negative 30. So that was number 39. I would not try and factor that. I'd just leave that like it is. Let's move on now to this last group that I'm going to do right now, which is going to be derivatives that involve trig functions. We've already done some of that, but there's going to be a whole section here with different trig functions. And sometimes there's some fun stuff we can do with trig functions. If the trig function is by itself in the denominator, we can rewrite it as its reciprocal trig function and make things a little easier for ourselves. So t squared sine of t is going to be u is t squared, v is sine of t, u prime is 2t, and v prime is cosine of t. F of t is u times v. F prime of t is u prime v plus v prime u. F prime of t is 2t times sine of t plus cosine of t times t squared. F prime of t is 2t sine of t plus t squared cosine of t. Now at 43. Says f of t is equal to cosine of t divided by t. So u is equal to cosine of t, v is equal to t, and u prime is negative sine of t, v prime is 1. F of t is equal to u divided by v. F prime of t is equal to u prime v minus v prime u all over v squared. F prime of t is equal to a negative sine of t times t minus 1 times cosine of t over t squared. So f prime of t is a negative t sine of t minus cosine of t all over t squared. Let's look now at 45. F of x is equal to a negative x plus tangent of x. Hopefully you remember that the derivative of tangent is equal to secant squared. If not, you're going to have to set up tangent as sine over cosine and use the quotient rule here. But f prime of x is just going to be the derivative of the first piece is -1 plus the derivative of the second piece is secant squared. So 1 plus tangent squared is equal to secant squared. So secant squared minus 1 is tangent squared. So f prime of x is tangent squared when we simplify. Let's go ahead and look at 47. g of t is equal to the fourth root of t minus plus 6 cosecant of t. So g of t is t to the 1/4 power plus 6 cosecant of t. The derivative with respect to t of cosecant of t is going to be a negative cosecant t cotangent of t. So we have the power rule on the first piece. It'll be a 1/4 t to the negative 3/4 power. And we're going to have plus 6 times a negative cosecant t cotangent t. So g prime t equals 1/4 t to the 3/4 power minus 6 cosecant t cotangent t. If you would like to rationalize that denominator, that'd be okay, but it's really not going to be helpful here. So I would just go ahead and leave that for now. Let's look at 49. '49 says that y equals 3 times 1 minus sine x over 2 cosine of x. And I would like to rewrite this. Y equals 3/2 is 3/2 times 1 over cosine is secant. Sine over cosine is tangent. So my y prime is 3/2 of the derivative of secant is secant tangent, and the derivative of tangent is secant squared. So y prime is 3 secant x times tangent minus secant x over 2. So if I want to bring that secant back down as a cosine, I can do that. Y prime is 3 tan x minus secant x over 2 cosine x, and that looks pretty close to what I started off with. Let's see, I have denominators of cosines for both of these, so I might still want to multiply by another cosine over cosine and make this turn into y prime equals 3 times sine minus 1 over 2 cosine squared. Let me refresh this whiteboard. Give me just a second. All right. And then we'll look at 51 now. Y is equal to a negative cosecant x minus sine x. So y prime is a negative, and then derivative of cosecant is a negative cosecant cotangent, and then derivative of sine is cosine. So y prime is a positive cosecant cotangent minus cosine. And I'm just going to leave it like that. There's no nice way that I can see to simplify that. Let's look now at number 53. F of x is equal to x squared tan x. So I see a product here. F of x is equal to u times v, with u equal to x squared and v equal to tangent of x. U prime is 2x and v prime is secant squared x. F prime of x is u prime v plus v prime u. F prime of x is 2x tangent x plus secant squared x times x squared. So f prime of x is equal to 2x tan x plus x squared secant squared x. And then we're going to finish up this video with number 55. So if y is equal to 2x sine of x plus x cosine of x, x squared cosine of x, then we're going to have two product rules. So let's call this function here f of x, and let's call this function here g of x for right now. And we know y prime is going to be f prime plus g prime, like that. So let's work on each of them individually here. So I need that to go down that far. F of x is equal to 2x sine x. So f of x is equal to a u times a v, with u being equal to 2x and v being equal to sine x, u prime being 2 and v prime being cosine, and f prime of x is u prime v plus v prime u. So f prime of x is 2 sine x plus 2x cosine of x. My g of x is x squared cosine of x. So g of x is also a u times a v, with u equal to x squared and v equal to cosine. U prime is 2x. V prime is a negative sine of x. So g prime is u prime v plus v prime u. G prime is 2x cosine of x plus a negative sine x times x squared. So g prime of x is 2x cosine of x minus x squared sine of x. So to come back now, y prime is equal to f prime plus g prime. So y prime is 2 sine of x plus 2x cosine of x plus g prime, which is another 2x cosine of x, minus x squared sine x. So y prime is equal to 2 sine of x. 2x plus 2x is 4x. Cosine of x minus x squared sine of x. And that'll complete this video. And we'll come back and we'll talk about even more problems from this section next time. But I think you can see, since we're already past 45 minutes here, that it was good to cut this up into 2 videos here. So we'll come back and talk about the next set of problems here in another video. See you for the next video.